let me ask you a question. Why does the Earth hang in space without falling? Don't rush to say universal gravitation. That answer is outdated over 300 years ago. The truth is even more outrageous. The Earth isn't suspended at all. It is rushing towards the sun every second, but it never crashes into it. It is like speeding on a circular track. You fall over every turn, but because of your speed, your body never gets thrown off. In 1915, Einstein completely overturned Newton as theory. He said, gravity, that thing doesn't exist. You can feel the support of your chair while sitting, right? That is a real force. But when the Earth revolves around the sun, does the sun pull it? No. There is a vacuum, 150 million kilometers between them, not even a rope. Einstein's explanation was brilliant. The sun craters the surrounding space. Imagine you put a bowling ball on a trampoline. The surface will dent, right? If you then throw a glass marble on it, it will roll along the dent towards the bowling ball. If the marble has a lateral velocity, it won't roll straight in. Instead, it will circle around the bowling ball. The sun and Earth are similar. The sun day's mass is 330,000 times that of Earth, and it has created a giant crater in the surrounding space-time. Earth slides within this crater. We call this revolution. So Earth isn't being pulled along. It is moving in a straight line along a curved space-time. Although in curved space-time, a straight line eventually becomes a circle. Sounds far-fetched. Someone proved it in 1919. British astronomer Eddington observed during a total solar eclipse that the path of light from distant stars actually curved when passing near the sun. Light travels in straight lines. The fact that light can bend only indicates that the space-time near the sun is inherently skewed. But here is a crucial question. If Earth has been sliding towards the sun's crater, why hasn't it fallen in after 4.6 billion years? The answer is simple. Speed. Earth currently orbits the sun at 29.8 kilometers per second. To put that into perspective, a bullet travels at about 1 kilometer per second. Earth's speed is 30 times that of a bullet. This speed allows it to keep spinning in the crater the sun has dug, preventing it from falling in. What if Earth suddenly braked in 65 days? Earth would plunge headfirst into the sun. Before that, everything on the surface would be scorched into gas by the sun's heat radiation. The good news is that this won't happen because there's nothing in space that can stop Earth. No air, no friction, nothing the speed Earth gained 4.6 billion years ago is almost unchanged. It will continue spinning until the sun goes out. You're probably wondering, where did Earth's initial speed come from? That goes back to the birth of the solar system 4.6 billion years ago. Somewhere in the Milky Way galaxy, there was a huge cloud of gas and dust called the protoplanetary disk. This cloud, under its own gravity, began to contract and simultaneously begin to rotate. Why does it rotate? Because matter in the universe inherently possesses angular momentum. There is a law in physics called conservation of angular momentum. Once it starts rotating, it is difficult to stop. Just as a figure skater's rotation speed increases when they tighten their arms, the protoplanetary disk does the same, accelerating as it contracts. Finally, the sun formed at the center of the cloud, and the surrounding debris coalesced into planets. Earth inherited the cloud's rotation, so it is inherently rotating. This speed isn't something pushed by anything. It is something it was born with. But speed alone isn't enough. Earth has been able to orbit stably for 4.6 billion years because it maintains a delicate balance with the sun. Too fast and it would break free from the sun's gravity and fly into the depth of space, becoming a rogue planet, eventually dying in cold and darkness. Too slow, and it would be swallowed by the sun's space-time concavity, falling into the sun and becoming a fireball. Only the perfect speed allows it to neither fly away nor fall, but to orbit the sun steadily. Where does this just right speed come from? The answer is harsh. It was filtered out by nature. When the solar system first formed, it was surrounded by countless fragments and asteroids. Those that were too fast flew away, and those that were too slow fell into the sun. Only those with the right speed survived to this day. Earth is the survivor of this brutal selection. More than 300 years ago, Newton conducted a thought experiment to describe this principle. He imagined a cannon mounted on a very high mountain, firing at the horizon. The cannonball, moving slowly, would trace an arc before falling to the ground. With a slightly faster speed, the arc would be longer. When the speed reaches 7.9 kilometers per second, the arc of the cannonball would match the curvature of the Earth's surface. In other words, the cannonball would keep falling but would never hit the ground because the Earth is round. As the cannonball falls, the ground also curves downwards, so the cannonball can never catch up with the ground, only orbiting the Earth. This is the origin of the first cosmic velocity and the principle behind the Earth orbit around the Sun. The Earth is falling at 30 kilometers per second, drifting sideways as it falls, so it will never collide with the Sun. In a sense, the Earth is constantly falling, only its trajectory keeps changing, eventually forming an elliptical orbit.